I was doing a question today with a student and the answer completely gone out of my head, although I knew I could do it, so I thought I'd turn it into a quick video. So we have two stars, Cygnus A and B, and we're asked to decipher or work out, could it be that these two stars are a binary pair? So a binary pair is a pair of stars that orbits around a common centre of gravity, kind of like this. So that means if you're observing these from planet Earth, they must both be roughly the same distance from the Earth at any particular point. Otherwise, they couldn't be orbiting each other. So this really is a question about how far away are these stars. So looking at the data, we have temperature. Okay, that's nice. Radius. Well, when I see radius, I think, well, that's a bit specific. There's a big hint buried in that. And also apparent magnitude. And apparent magnitude, remember, is we can use that to find out a measure of how much energy is arriving on planet Earth. We'll come to that in a minute. But first of all, I look at this and I think, well, let's work out the power that's the power that's leaving each star. Well, that's worked out using Stefan's law. There's a constant, the surface area, that's what the radius is for, and a temperature. Now, I'm a big fan of using spreadsheets for these sorts of calculations if you can. So I did it for the two stars here. The last column there is showing us the power of each star. So you can see that they're both of the order of 10 to the 25, but there is a difference between them. So now we know the power, which is another way of saying luminosity, which is the energy leaving the star per second. We also have in this table the apparent magnitude, which is a measure of the energy arriving at the surface of the Earth. And as you probably recall, there's a formula that gives us the ratio of the intensities. So I'm going to say IA over IB is going to equal to a strange number, 2.51, to the power of MB, which is the apparent magnitude of B, take away the apparent magnitude of A. Now, if you want to know more about that, I've made a video on that, and I'll leave the link to it in the description. So this means that the intensity of Cygnus A over Cygnus B is going to be equal to 2.51 to the power of magnitude of B, which is 6.1 minus 5.2, which is magnitude of A, therefore 2.51 to the power of 0.9. So when you work that out, you get the intensity of A over the intensity of B equals 2.289 ... This figure here tells us the ratio of the intensities of star A over star B, 2.289 ... So that's what's arriving on Earth. Now let's consider what's leaving the stars. So the luminosity or power of A over the luminosity of B is just those two figures at the end now. So 6.45 times 10 to the 25 divided by 3.38 times 10 to the 25. And that equals 1.9. Since the energy leaving Cygnus A is about twice as much as leaving Cygnus B, and the intensity arriving at planet Earth is around about twice as much for Cygnus A as it is for Cygnus B, we can therefore conclude that it looks as if they're a binary system, because these ratios are the same, and you know the intensity of the radiation leaving the stars would change with the square of the distance. Therefore, since these ratios are the same, more or less, that means the distance must be the same. So they could be a binary system. Notice the question says supports the suggestion that they are binary. It doesn't say show that they are a binary, just that, well, you know, they're not too far out, these two numbers, so it could be.